recordings. Okay, Garrett, you want to give a shout out to you guys here?
It's on YouTube.
Oh, interesting. Well, very nice, Garrett. Garrett, anything you're a little bit bitter about today?
I'm just a little tired.
You're also sad about your lunch.
Yes,
Why are you sad about lunch?
because I don't want to split my math class.
Oh, all right. He's saying that he cares about his learning. Very good. We'll try to believe that. All right, here we go. Let's flip to the front. Today we talk about trigonometry. You guys love algebra. It's why you started to love mathematics. You love this whole idea of 2x plus 1 is equal to 9. Hey, I'm going to solve for x. You see, once upon a time in math, you were able to add and multiply and solve equations quicker than the other kids. And you were then dubbed as advanced. Do you remember that? Do you remember that? Yeah. Guess what, folks? Algebra is done. We don't care really how good you are at algebra anymore. It's over. In fact, some people say algebra gets kind of boring after a while, and I would have to agree. Because when we start talking about trigonometry, we're talking about mathematics the way mathematics was kind of generally intended to be. Did anybody read the Iliad or Odyssey? This all trigonometry comes back to the single one idea. And the single idea is a squared plus b squared is equal to c squared. The Pythagorean theorem. That's where it all starts. So what about that? Well, what we do is when we take trigonometry, a lot of times you think of trigonometry, think of SOHCAHTOA. Does that sound familiar? I'll tell you a story about that later, but we do kind of this background of where this SOHCAHTOA idea comes from, and it's called the unit circle approach. The formula for a circle is x squared plus y squared is equal to r squared. Do you remember that? There's a reason why we taught you that. These two, are they similar? Yeah, they're the same stinking thing, aren't they? So all of trigonometry comes from the Pythagorean theorem. We start with the unit circle. What is the unit circle? It's x squared plus y squared is equal to 1. 1 unit is the radius. You see, the center of the unit circle is 0, 0, and the radius is 1. The center is 0, 0. The radius is 1. Now, if you think about that, if we call this the unit circle, it's sitting on the x and y axis. If it has a radius of 1, what would this coordinate, the xy coordinate, be right there? 1, 0. That's a point on the unit circle. How can I confirm it's on the unit circle? If you plug 1, 0 into this equation, do you get 1? Yeah. 1 squared is 1. 0 squared is 0. Add them together, you get 1. Let's find out 3 other points that sit on the unit circle. What's this coordinate right there? 0, 1. How about this coordinate? Negative 1, 0. And this coordinate? 0, negative 1. Let's see if this is useful. Maya, have you had to use this in the past few months at all? Yes, it does not go away. Long-term memory, not short-term memory. Not Quizlet stuff that you just read and forget. This, permanent. Lodge it in your brain. It turns out that this is also a coordinate on the unit circle. We're going to show that it is. I happen to know that the root of 3 over 2 is approximately 0.86, and negative 1/2 is negative 0.5. If I go over 0.86 and down a half a unit, I get to be right about there. I'm going to show that that is on the unit circle. How do I do that? I plug it in for x, and I plug it in for y. So I have the root of 3 over 2 squared plus negative 1 over 2 squared. Let's see if we get 1 when we plug those in. What is the root of 3 over 2 squared? Square the top. 3. Square the bottom. 4. 3/4 plus. Square the top. 1. Square the bottom. 4. And I get 1. Someone says Nicole. She is correct. We have confirmed it is on the unit circle. We have a point P that lies in the third quadrant, somewhere down here on the circle. The x coordinate is negative 2/5. So that means it has negative 2/5, but we don't know the y value. We would like to find point P, or rather find the y value. We're going to use the definition of the unit circle in order to find that. negative 2/5 squared plus y squared is 1. What's negative 2/5 squared? 4 over 25 plus y squared is equal to 25 over 25. I'm going to take time to rewrite that right now because I know I'm going to have to add stuff over, right? Subtract my 4 25ths over, I get y squared is equal to 21 over 25. I square root both sides. When I square root y squared, I have to list both the positive and the negative. So y is equal to positive or negative root of 21 over 5. Can somebody tell me, is the y value here positive or is it negative? Why is it negative? Third quadrant sits below the x-axis. Very good. So your coordinate is negative 2/5 and negative root of 21 over 5. What do you think? Not too bad? Part of what we have to do is we have to talk about angle measures. A lot of mathematics and trigonometry has to do with angle measures. Now, we have to be able to deal with different types of measurement. For example, I drove from Owatonna to Albert Lea today, and I traveled approximately 32 miles. But if I wasn't from the United States, and I said, I would never say I traveled 32 miles, would I? If I was from England, I would say I traveled 1,000 kilometers. Wow. Maybe more like, say, 55 kilometers, something like that. Okay, but thank you. Yeah. Right? We do kilometers and miles, right? Everybody agreed? Now, we're kind of the weird ones in the world, right? We're the ones that hang on to this idea of using this standard type of measurement as opposed to the metric system, right? Okay. Like my weight, I'm approximately 186 pounds, which is like 80 kilograms. How many pounds are there in a kilogram? Do you know? 2.2. How many centimeters are there in an inch? 2.54. So we're going to talk about a different type of angle measurement when you get back from lunch. Hey kids, anybody have pizza for supper last night? You have pizza? Where'd you get it from? George's? There's a George's Pizza. Oh, awesome! You drove all the way to Austin to get pizza. You live closer to Austin, you do Albert Lea, but you choose Albert Lea. Austin's Austin. Buses don't go out far enough. They don't have good enough buses. Wow. Okay. Well, give John a round of applause. That's it. We're so happy to have John here. John, thank you. So we're pizza. So you have pizza. Good for you. All right. How many slices do you have? Like you get pizza, I'm having squares. Just work with me here. 3 slices. Okay, that's good. Last time we had pizza, we had from Aldi, super cheap pizza, but actually not too bad. Okay, fed the whole family for like $5.50. They get 3 slices, cut it into eighths, so there's 16 in the 2 pizzas, and then we each get 3. There's 5 people in the family. 1's left over. My wife probably had for lunch today. That's how we go. But what if we measured instead by number of slices? What if we measured by like degrees? I'm like, hey kids, you all get 1 degree of pizza today. Like you think like that would be just a little sliver, wouldn't it? But you think about degrees. This would we mark this as 0 degrees. Mark this as 90. This is 180. This is 270, and this is 360. So 360 and 0 is the same spot that's once all the way around a circle. But that's how we label the degrees of measurement within a circle on the coordinate plane for the unit circle. And instead of using this measurement x, which is a variable that we use in algebra, we use this Greek letter theta. It's spelled T-H-E-T-A. Okay. And theta is the Greek letter for T-H. So we have 2 letters to make that sound. They had 1. And, you have, different measurements. So, you want to, like, measure, I don't know, 160 degrees. Theta is 160 degrees. Okay, I tell the kids, hey, kids, You get 160 degrees of pizza today. Yay! That can be fun, right? My kids are kind of mathematical. Maybe they're not all to that spot yet, but like the oldest, I could tell her that. She's like, hey, Dad, how many slices do I get? You don't get slices. You get 135 degrees. She'd start laughing. She'd like that. But all of a sudden, I tell my kids, you get 1 degree of pizza today. I mean, that's 1/360th of the circle, right? Like, that's not very much, is it? Like, they would be sad. Dad, can I have more pizza? No, get a job. Start contributing, right? Did you ever wonder, too, all sorts of good things to write about. I don't know why they got 1/360th, but the question is, what is a radian measurement then? How does that compare to degrees? If I told my kid, you get 1 degree of pizza, they would be sad. If I said you get 1 radian of pizza, they'd be like, okay, that's good. Okay? Because it's definitely more than 1 degree. I'll tell you that right now. How do we measure it? This is where you're going to start to kind of make associations, understand where it comes from. I could just give you the formula, but I don't want to. I want you to think about it. The key word in radian, the key part is radius. You see, there's a little arc here. You see this 360th thing right here? There's a little arc. See that angle, it cuts off an arc, right? And that arc is 1 degree. You learned that in geometry, remember? Everybody agree that arc length is a lot shorter than the radius? A radian occurs, 1 radian is when the arc length is the same length as the radius. So for example, suppose this is my radius right there, and I have that angle. Is the arc length more than a radius or less than a radius? More. Everybody agree that the red is longer than the radius? That's more than 1 radian. Oh boy. Try again. If at first you don't succeed, try again. Okay. The red, is that shorter than the blue or longer? Sure, so that's less than 1 radian. So it's got to be somewhere in between the two. I need a volunteer. Who's my volunteer? Garrett? Garrett. Here we go, Garrett. Garrett, you are going to tell me when what I draw for the arc when you think that it's approximately the same length as a radius. We've shown you too long. We've shown you too short. And if you get it wrong, don't worry. We'll let you try again. Are you ready? Further? Further? You tell me when. What do you guys think? Think pretty good? Anybody think I should go further? If you think I should subtract some off? Raise your hand if you think I should go further. Raise your hand if you think I should subtract some off. Oh, Maya's saying subtract some off. Maya, tell me when. Maya, you're way off. That's totally wrong. I thought you took this class. No, I'm kidding. I'm just totally joking. No, Garrett is pretty close. It would be right about there. A lot of people say, well, that looks a little bit less. Well, remember, it's curved, right? It's curved. So that is approximately 1 radian right there. And so I'm going to draw a second radian. That's about 2 of them. So Tenley, you get 1 radian of pizza. Micah, you get 2 radians of pizza. Kiera, you get 3 radians of pizza. That's about 3. That's about 4. That's about 5. That's about 6. There's a little bit more than 6 radians that fit within 1 circle. A little bit more than 6 that fit within 1 circle, okay? A little bit more than 6. 6 point something. What do you think? 6.4? Less than 6.4. 6 point, more than 6.1. 6.2, a little bit more than 6.2. 6.25, a little bit more than 6.25. More than that, 6.28. Yeah. Yeah. And that's actually an approximation. The number goes on forever. It's double pi. You see, look at what I've drawn, folks. There's 1 radian, 2 radians, 3 radians, and just a little bit more that fit in 180 degrees. It turns out that 180 degrees is exactly the same as pi radians. 3.14 radians is 180 degrees. And 6.2 radians, or 2 pi, is the same as 360 degrees. And there is our conversion. There is our number. Just like I told you that there's 2.2 pounds in a kilogram, there are pi radians that fit within a degree, or within 180 degrees. That's the conversion back and forth. You already knew this, folks. Tell me, I asked you how many radiuses wrap around a circle. What do we call that measurement when you wrap something around a circle? Circumference. What's the formula for circumference? Don't say pi r squared, that's area. 2 pi r. How many radiuses are there around the circle? There are 2 pi of the radiuses. See that? So there are 2 pi radians. So here is your conversion. Degrees to radians, you take theta, whatever the angle is, you multiply it by pi and divide it by 180. That's our conversion. If you want to go from radians to degrees, you take theta and you multiply it by 180 and you divide it by pi. That's a straight up formula, but it's better for you to think about how it's actually constructed. So I'm going to have you participate and cooperate in producing what we call the unit circle. I like to refer to as the circle of life. Some trig students refer to as the circle of death. I try not to think so pessimistic on day one. Think about circle of life, kind of a little, you know, Lion King type stuff. Anybody want to sing for us? Henrik? No? It's 4th hour, so generally we don't have a lot of just great singing people because this is the same hour as choir, right? But not that you're not gifted. We'll let you do a solo tomorrow. Okay, Emma's going to start class with a solo tomorrow. Very good. Thank you, Emma. This is 0 degrees and 360 degrees. I'm going to write the radians in red, 0 radians, or 2 pi radians. From that one piece, I'm going to produce all of the others. Have you ever been in a class where you were only 20% present in that class? Where you were there, but your mind was really only there 20% of the time? What kept you from being there the full time? Be honest, we won't judge. Yeah. Okay. If that's 2 pi, what's this? 1 pi. And it is 180 degrees. Are we all clear with how we produced this so far? I'm now going to move to half of that. How many degrees do I have now? 90. Great. I've got 90 degrees. So if 180 is pi, then 90 degrees would be 1/2 pi, or pi over 2. Please notice that these all have, a lot of times people say, well, a radian has pi in it. No, not necessarily. If I wrote 3.14, that would be the same. If I wrote 1.57, that would be the same, okay? The difference is that the degrees have a degree marker on them, whereas radians do not have a marker on them. Do you see that? Got that little symbol. Okay, great. Well, what's half of 90? 45. So how many radians would that be? If 90 is pi over 2, then 45 would be pi over 4. Hey, let's take that 180 and let's divide it into sixths. 180 divided by 6 is 30. So let's mark off 30 degrees. Cool. And that's going to be pi over 6. See how I'm producing these? I'm going to take 180 and divide it by 3, and I'm going to get 60. So that's going to be pi over 3. Exactly. Why am I choosing these? Number one, they divide easily. Second of all, it's very useful in geometry because you have some special triangles we're going to work with. Remember your 45, 45, 90 triangles? Remember your 30, 60, 90 triangles? Those are triangles we're going to work with, and these are excellent measurements to be able to reference from time to time. So now, next time my kid grabs a slice of pizza, they say, how much should I grab? I'll say, grab pi over 4. Well, that's just 1/8 of the pizza, isn't it? Or it's a 1/4 of a half, right? So that's how we can think about it. Now, what we're going to do is you need to be able to produce these red marks for all the rest of it. And I'm going to show you how to do it quickly, okay? Write down the degree measurements. We're going to do 120, 135, 150, 210, 225, 240, 270, 300, 315, 330, and 360. What time do we go till? 2:10, right? 12:10? No. 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 You're serious? Wow, Hensch's birthday threw us for a loss. That's all right. We'll pick it up tomorrow, but we're going to finish as much as we can here. I need a volunteer. Just look at these right here. Okay? Let's take his 300 for example. Which one of these divides into 300? 30 and 60. This one's the bigger one, right? How many times does 60 go into 300? 5, right? So it's 5 of those. 5 pi over 3. Which one of these divides into 120? Yeah, 60 is the bigger one. How many times does 60 go into that one? Twice. 2 pi over 3. Which one goes into 150? 30. How many times? 5. You have 5 pi over 6. The ones that end in 5, they're divisible by the 45. Folks, I don't actually divide it. I just think about it. I've got 1 of them, 2 of them. I've got 3 of them. 3 pi over 4. $210. What goes into $210? 30. How many times? So it's 7 of the pi over 6s. 225. Uh-oh, that's a 45 one. How many 45s fit into the 225? There's 5 of them. 5 pi over 4. Folks, we'll just finish up these and you could go. Just work through the bell if it goes. 240, which one divides evenly? 60, how many times? 4, so it's 4 of the pi over 3s. Got 3 left. 270. 90, it's 3 pi over 2. 315, that's one of those pizza slices again. How many pizza slices? 7, 7 pi over 4. And what divides into 330 evenly? 30, how many times 30 go in? So it's 11 of the pi over 6s. Wrap it up there. We pick up with that tomorrow. No assignment today. Be ready to do some work in class.